AP Calculus, you have been asking for a video, and I finally have not one, not two, but 3 videos for you. This is the first one, and in this, I want to give you the last example on your separation of variables notes. Actually, it's the 3rd example, but we did the 4th one together. Well, maybe we didn't actually. Well, anyway, I think you need to see this example. So we have this equation, xy plus y prime equals 100x. It is a differential equation because it's an equation that involves the derivative of y, and we want to solve that equation. So the first thing we're going to do is get the y prime by itself, and I'm going to change that to dy dx. So my y prime is dy dx, and that's going to equal 100x minus my xy term. Now, we've said that to separate variables, we need to do that through multiplication division, not through addition and subtraction. So for me to get x and y separated, I'm actually going to have to come to this left side and separate x and y here. And I'm going to do that by dividing out the common factor we have of x. So that gives me dy dx equals x times 100 minus y. Now we can separate our variables through multiplication and division. So I'm going to multiply both sides by dx. Right, that's going to divide that out and put x on the right side, and then I'm going to come in and divide both sides by this 100 minus y, and that gives me dy over 100 minus y equals, right here my 100 minus y divides out, and I have x times dx. And I've done that all-important step of separating my variables. My next step is going to be to come in and to take the antiderivative of both sides. Well, I don't have a formula that fits dy over 100 minus y, so we're going to use the idea of substitution. So I'm going to come in here, and I'm going to let u equal 100 minus y. And as we do, I'm going to take the derivative of both sides, and I get du equals negative dy, which means if I divide both sides by a negative, that negative du equals dy. So that gives me a substitution for 100 minus y in terms of u, and a substitution for dy dx. So we're going to come in here, and we're going to make those substitutions. So we now have the integral of not dy, but negative du. So I'm going to bring the negative out, and then there's du, right, over, or times 1 over, not 100 minus u, but u. That fits an integration formula, so we're set up. And on the other side, we have the integral of x dx. Right. So anti-differentiating on this left side, I have my negative. The antiderivative here is the ln of the absolute value of u, right, plus c, but we're going to put that on the other side. And here we get 1/2 x squared plus c. So we have that variable out of our integrals. So now we're going to anti-differentiate, or we're going to use our circle rule. So starting with the unwritten base of e, we're going to rewrite this as, oh, I can't do that with the negative in there. So let's back that up a minute. So we're not going to do this quite yet. All right, we'll take this out. And we will divide both sides by a negative, which gives us our ln of the absolute value of u equals now negative 1/2 x squared. Right? And technically it's minus c, but because we don't know whether c is a positive or negative, we can just leave that as plus c, plus some constant. Now we're going to do our circle rule, and we will rewrite this as e to the negative 1/2 x squared plus c equals the absolute value of u. So that would be that the absolute value of u equals e to the negative 1/2 x squared times e to the c, breaking up that power as a product of two powers of the same base, which is the absolute value of u equals, right, e to the c is some constant, times e to the negative 1/2 x, which gives us that u is equal to plus or minus c times e to the negative 1/2 x. And again, because c could be a constant, we don't know what it is, we can just leave that as c. So we get u, which is 100 minus y, is equal to some constant times e to the negative 1/2 x. Solving this for y, I get negative y equals negative 100 plus my constant times e to the negative 1/2 x. Dividing both sides by a negative, right, dividing through by negative 1, I get y equals positive 100, right, minus, right, but again, c could be positive or negative, so we're just going to make it plus c e to the negative 1/2 x. And that would be our answer for y. So that's that example. So I think I'll leave it at that. The fourth example just does what we've done before several times now, except it, no, let's do it. So I'm going to come in here now and I'm going to do example 4. Let's do a new page. So we'll do example 4, which gives us to find y if dy dt equals ty that passes through the point 0, 1/2. So this is a value for t, this is a value for y. So we're going to start here. We've done this many times now, and we're going to separate our variables. So dy over y equals t dt. We're going to anti-differentiate both sides, so we get the ln of the absolute value of y equals 1/2 t squared plus c. Applying our circle rule, we get e to the 1/2 t squared plus c equals the absolute value of y. I can do this. I'm actually going to back up, and I'm going to take this out. Right? At this point, we have already integrated, and if we plug in our point, we've got this point 0, 1/2. It's going to make finding c easier than if we go farther. So when we plug that in, we get the ln of the absolute value of 1/2 equals 1/2 times 0 squared plus c. So that gives us the ln of 1/2 equals just c. So c is the ln of 1/2. Okay, now we come in and we get from here, right, so combining this with this, we get the ln of 1/2 equals, no, I'm sorry, we get the ln of the absolute value of y is 1/2 t squared plus the ln of 1/2. Now using our circle rule, we get e to the 1/2 t squared plus the ln of 1/2 equals the absolute value of y. This is a 1/2. So we get y equals plus or minus, breaking this up into the product of powers, we get e to the 1/2 t times e to the ln of 1/2, which is y equals plus or minus e to the ln of 1/2 is 1/2 times our e to the 1/2 t. Going back to our initial condition, if we know that the point 0, 1/2 is on our graph, then we would have to have 1/2 equals plus or minus 1/2 e to the 1/2 times 0. 0 times 1/2 is 0, and e to the 0 is 1. So we get 1/2 equals plus or minus 1/2, which is 1/2 equals 1/2. So we have y equals the positive of 1/2 times e to the 1/2 t. So that t is up in our exponent. Okay. And that completes our separation of variable notes. So hopefully, especially that example 3 will help you in those unique situations.